Welcome everyone in this new live development video tutorial about building an auto chess game. In this video, which is not a tutorial, it's a live development, as I just said. In this video we're going to start rebuilding the logic to enable the combat in the game. So when we play, if we put some units on the ground and we hit start combat phase, we can see they are ready to fight and we need to re-enable their fight. So we're gonna do this in two steps. First, we're going to re-enable the small logic we had, which made our unit walk towards each other and fight each other. And after that, I think we're going to take care of the ability system and take care of making our units able to fight each other with more than just simple melee attacks. Because I don't know if you remember, but the logic we're going to re-enable is just going to make units able to fight each other using melee attacks. So this is the first steps we're going to follow. We'll just take a quick look at the order we wanted to develop stuff. So we've done a lot of stuff here. This is not what I wanted to do. I think this is what I wanted to do. So we've done this, we've done that. We've done the ready system. We started the color selection, but we can no longer select our color, so we'll leave this for now. We didn't package and we didn't build the loading system. We've made our map setup, we've made our player base, our actor pool, and unit pool we didn't. Phase management, we started to do this, but it's halfway through. Income we didn't touch. Bench, purchase, reroll, upgrade, promotion, and add events. We won't be doing this right now. And this and that. We'll go over this because it actually allows us to finish our phase management system, because we need units to be able to fight each other and die in order to finish the combat phase. So that's pretty much it. So that's why I think we need to do the units logic. So let's dive right in. So what do we need for the units? The units need to have a way to find what target they need to focus, and for that we'll do something like fight zone are going to communicate with the game state, and they are going to give it all the reference to a player's unit, and when a unit wants to know what unit it has to focus, it's going to communicate with the game state and ask it what is the closest or the target with the highest priority, what is the closest one, and it's going to give it its target then, and it's all going to pass through the behavior tree of the unit, I think. So we need to keep track of all the units players have, and we're going to open up our in-game state to start thinking about how we're going to do that. So we have an old player in here, we have an old player, and we have a new player here. Players, new players. So I think this is far from being clean. But we don't care about this. We don't care about this right now. I'm just wondering where we're using this. If we have enough player, we're going to the recruit phase. And in here, we're asking for the amount of player remaining. In both cases, we're doing this. Okay, so I think we don't care about this for now. We'll just go ahead and create a new variable called players units, which is going to be a map of string with a list of units there, combat units we want. And I think we're going to have a new function called add units to player, and this is going to be located in units. And what else do we want to do? For now we'll just do something like this. For that player, we're going to add that unit. These are not going to be passed by reference. For player in units, like this. And we'll also say that when we come over the recruit phase, we're going to clear all units players have. No, we're not. No, we're not. We're actually going to do this when we go to the combat phase. New combat data. So these are we want to find, we want to break. I just want to check something real quick. Yeah, we have a list of units we need to be spawning there, and this is so this is actually only on the server. So this is basically the same thing than this, except it has direct everyone gonna have this. So when we go to the combat phase, I think we want to be clearing this, because we're going to fill this here. Because when we go to the combat phase, the phase starts, so we tell units to spawn there. Where do we tell? When do we tell units to spawn? Go to phase, go to combat phase, await combat data, spawn units. Okay. So yeah, we indeed need to be doing this before that. We need to be calling our clear before doing this, yeah, because sending units to the combat will be filling that array. So it's gonna call that, no, not this, that function it's gonna call. So the game set is gonna have a reference to all the units for a given player. So the grid needs to be calling this. Get game state ref. So when we record a unit on unit registered, we want to grab our game state ref, and we want to be adding at unit to player. So we are setting its team color, and we also want to add unit to the game state for that player, and this is going to be that unit. This is going to be a combat unit. It could be a unit. We could be avoiding that cast by just making this a unit. I think it should work the same way. And maybe we actually need to be doing this, I'm not sure. Because now I think we're okay with this. So the in-game states as a reference to all units currently on the fight zone for a given player. So we also need to be able to find. So we need to be able to find the highest priority target. Get highest priority target. It's gonna take a unit as reference for a unit, and it's gonna do units have a reference to the hosted player? No, they don't. I think they do need to have a reference to their player. I think we do need this. So if we open up our units in here, we're gonna have a new variable called owning player. We could be finding that player through team, but no, because several players could be of the same team. So we need to be able to find who's the player, who's the owner of that player. And for that we just need to say that when we register a unit, we're going to set its hosted player, set owning player to the hosted player of the grid, like this. So get highest priority targets, for a unit, it's gonna find. So I think for a unit we want to get the hosted player, get owning player. We don't want to get current match, I think. Well, yeah. I think we do need to find. We need to know who is that player up against to be able to know in which entry of the player units we need to be searching for. So we need to grab the battlefield. Not the battlefield. We need to find the fight zone. And we actually need. Yeah, we need to be able to find the opponents to that player. So how are we feeling that? Get player battlefield. Yeah, we can get the battlefield of that player. Player current battlefield. So I think stamp opponent. Yeah, okay. Okay, so we are storing all of them in this. So we have, oh, that's in update battlefield. Yep. We're gonna put this in matchmaking. So all players are inside that variable. So we need to have find opponent's player. This is gonna be in matchmaking. It's gonna take a string as parameter and it's gonna return a string as parameter. It's gonna be pure for player in opponents like this. And we're gonna loop through current match. Like this. And we're gonna break. And we're gonna be looking for, we're gonna loop through current match and we're gonna look for the opposing of that. We want to promote that temp opponent ID. So what is going to be this? This is going to be X in the same battlefield, but in the other fight zone. So if this is equal 0, we're gonna look for 1, and if it's not equal 0, we're gonna look for 0. So this is what we're looking for. So we want to be looping through all the keys here, except the one of our player. So if we're looping through another guy than our player, we're gonna look for the key at that location. And if this is equal, we don't want nearly equal, we want exactly equal. Do we have this? Equal exactly. If they are equal exactly, this means that guy is our opponent, temporary opponent, and we're gonna return this, and we're gonna break actually our loop like this. We're gonna delete this, and when we find our opponent, we're going to break the loop. We might not be finding any opponent, but for now it doesn't matter. Alright. So we want to be finding the highest priority target. We want to be finding the opponent player of that player. And we want to be looking for now we'll just be looking for the closest units in the array. So we want to be finding the closest units there. Oh, yeah, we need to make that. I don't know if units, we want to change the variable type. It's gonna throw errors at us everywhere. If we break this, yeah, this is an array of units. And I guess that is exactly what we want. Yeah, so this looks like exactly what we've done for our fight zone debugger. So we want to find the units of that player. We want to break, we want to promote that to a local variable, temp units. We want to be adding to that array, we want to be adding the newly created, the newly registered unit. And we want to add that player with that array. Like this, and we have another error, not that one, this one. So we're gonna clear that map over there. And when we try to get the highest priority target, we're going to look through all the units of the opponent. And we're gonna look for now we're just gonna look for the closest one. Get distance to 4 units. Is that distance is inferior to shortest distance. Shortest distance is going to be like 10,000 by default. So if the units we are finding there has the closest distance to than the other units, we're going to promote them to a local variable, which is temp targets. And we're going to store the distance here, the shortest distance, when we set that. And then we're going to return that value, that target. Return value. I think we can safely make this pure. So the in-game state has a reference to all units of a player. We'll just add a little print here to see if it says what we want to say, what we want to hear. So for example, if we play with 2 players and the server drops 1, we should be seeing 2 prints. Yep, it knows that, so this is working. So we can be looking for this. So then what? Then we need something that we need to re-enable our unit AIs. And for that, we can go to our in-game state and see what happens when we're starting to, when we receive combat data, await combat data. When we received all the combat data, we are actually spawning units. So we actually need, we'll make this a function called on combat data received. So when we receive combat data, we spawn all the units. And I think we're just going to enable all units there. we are spawning all units, they are being teleported, they record, and actually now the server has to wait for when we add the units to the player, the length of the array here must be equal to the amount of units in that array. So when we add a units to a player, we want to check if so add unit to player. In here we want to await units ready, for instance. I don't like the name, but it doesn't matter. So when we add a unit, we're gonna check if we're gonna loop through that all the units of all players, and we're gonna check for the length of the amount of units which registered compared to the amount of units that were supposed to be there. Like this. And then what we want to do here is, if they are all equal, we can start the game. We can actually not start the game, but start the AI. So yeah, so if they are not equal, we're not going to be able to start. If one of them is not equal, we're going to break the loop and we won't be able to start. Like this, like that, and we'll need to store that value to store the fact that we can promote to local variable b can't start. Okay, just can't start, and we don't want to be using this here. We just want to grab that, pull that here, can't start. So branch, if we can start rather than can't, we're gonna launch AI, launch unit AI. Like this. So we are doing this makes it certain that all units are ready, and we want units to be ready server side, because the server is going to handle everything regarding this. So if all units are ready, we're going to start the game. So we'll see what it says in here. If I print, does it start the game? Ah, we don't want to print here, we want to print there. Does it start the game? We want to be adding like this, and we want to start, and apparently it doesn't work. So why doesn't it work? Are we triggering this? Seems like we are. 2 units are being added. We're checking for the length. If the length is different, it means we can't start. Can start is true by default. We want it to be false by default. And it's gonna work. So we want to get rid of that print, else we won't be able to see that it's working. Like this. So we want to start. So yeah, units are ready. This is what it says. So in there, we want to grab all units and tell them to start fighting. So but we actually have array of units and not array of combat units, and that's kinda silly. So I think, oh no, it doesn't matter because we can tell them to go looking for targets. So we're going to loop through all of them. We're going to loop through all the keys, all the values, my bad. Like this. We're going to break this. We're going to loop through each and single unit. And we want to set states to looking for target. So they are static when they enter looking for targets. The first time they enter looking for target, I think we want to enable their behavior tree here. We can't be running their behavior tree, we need to be getting their AI controller. We want to be running a behavior tree here, which is going to be our BT unit. And then we want to set unit state. Actually, the other way around, I think. Like this. So this is gonna work. We just want to check if what does our unit controller and BT unit says. So when it spawns, it's running a behavior tree. We don't want that anymore. And the behavior tree, yeah, we are actually never setting these values. So we need to be setting them somewhere. So I think we're doing some kind of stuff here when it comes to unit states. Yep, we're setting the value as enum. So this is perfect because we're telling. So the in-game state is actually adding the behavior tree here, and I think we want to do this before actually, like this. So we're adding the behavior tree, we're telling the unit to be looking for targets. When the look, so it's waiting all the time here, but we don't care about this. We'll just leave it for now. If we are looking for target, we're trying to find the closest target. And in here, we're actually going to build up our logic to grab the game state, which is going to be pretty efficient. So we're going to create a new variable called bb game state, and it's going to be a keyboard, a blackboard key selector, which is going to be public. We're going to compile this, add over our BT unit, move to our blackboard, create a new key, which is an object. This is going to be the game state, and this is going to be synced. So all actors using that blackboard are going to have the same value over the game state. This is going to be an in-game state by default, like this. And if we go back there, grab our game state, we can get value as actor. We can cast into our in-game state, and we'll actually promote that to a variable called owner ref. We'll actually create a new function, get owner ref, and another one called get game state ref. In the event graph, we want to get rid of this. Get game state ref, we want to pull that here. We don't want to create a function, a variable out of this, because this will lose us the benefits of having the value in the blackboard. So like this is going to be pure, but the owner ref, we want to be storing this into a variable. So do we have a owner ref? Owner control pawn. Can we get the control pawn? We can get the control pawn here. No, we can't. Okay. So I guess we need to be doing this. Oh, no, we can't be doing this. We need to be doing that. Yeah. In pawn, this is gonna take a pawn as parameter. Well, actually, not at all. We don't want to do this. We want to set owner. We want to set owner ref. This is gonna take a pawn. And we don't want to do this. We want to go there. So when we receive execute AI, we want to check if our pawn is valid. Okay, so we're gonna do a function after all. So if it's not valid, we're going to create it. So this is gonna be a function set owner ref. So when the task begins, we want to be setting our value here, who is owning us, and then we want to grab our game state reference and find targets, highest priority targets, get highest priority targets, what units our own, and this is going to be the value here. And this is the moment when we'll be looking at if is the logic working. So the game state is going to be the game state here. We have to remember doing this. So we're going to finish execute in here. Blackboard state equal to looking for target. So first we want to find the closest target, and then are we at location? If not, we're going to move to. I just want to hit play. I'm just too curious. And they're not moving. But it might be working. So what's going on there? This unit doesn't have an AI controller. So we're gonna add the AI controller. And I think the AI controller is actually not replicated. It should not be replicated. Yeah, only relevant to owner, exactly. Only the server has reference to that. So if we are adding guys there, they're still not moving. Get game state ref. Yeah. We're never setting. We're never setting this. So if this is valid, we're just going to cast. If it's not valid, can we get the game state out of here? Yeah, we can. We're going to set Blackboard key as actor, as object, like this. And we're going to go back there. So we're going to add this here, add this there, hit play. Still not moving. We might not have nav mesh there. So we're gonna add like 4 nav meshes. I don't know if that's, I don't know. I think it's better to add 4 nav meshes, because if we have to rebuild one, it's not going to rebuild the others. So there are many reasons which should make it so units are not moving there. Oh, okay, so they are moving, except they don't move. So this just comes from their, I'm just going to close everything. It just comes from their movement, I think. Or maybe their collision settings. This does not block anything. This blocks the ground. This blocks pawn. Is this a pawn? It's not a pawn. Does this block world dynamic? No, it doesn't. So why would it not be moving? Max speed 1200, it's fine. So for some reason they are failing to, oh, because I think we never activate this. So I think they are gonna move towards each other. Yep, we're gonna reduce their speed, and we'll see why this is not working. So they are gonna be like pretty slow, like this. And we were having errors, and we don't have them anymore because we pressed play again. So yeah, there, and we might have errors there. Okay, so why do we have errors? Because this doesn't manage to so I guess we can do that. I think we might be doing this instead of actor, but even if the game state is actually on actor, that might be because this is actually pure. If we remove it from the pure logic, because it behaves differently when it comes to execution flow. Now we still have the error. When we try to set the blackboard value as object, it says it's failing to find the game state ref. So this is throwing null. The first time it is performed. So why is it so? So the first time that we enter that logic, I think we can cheat the logic here by saying this. Oh yeah, okay. Because we can't be looking at that value here after doing this. It's only going to be valid the next time the task runs. And we don't have errors. Oh, I was certain we were not going to have errors there. Instance synced. And we have one error per units on the battlefield. So why is it so? If we go back to our behavior tree, grab this, we do have target in game state. So it's kind of strange. Because it's finally working, which means we're setting the blackboard value as object here, so this should be. And what if it's not synced? Does it behave the same way? I think it should. Yeah, it behaves the same way. This should be synced. Hey, hey. So the logic is working, but there are errors in the code. So that's kinda strange. For now, we might just be saying, is this is valid? We're going to go ahead. And if not, we need to finish execute with a fail. And we don't have an error. So we kinda went over what we wanted for that video. We have, if we increase the amount of players, we'll have units moving at each other on all screens, supposedly. So that guy is like all in on. That guy is like all in on all the Wolf Rider. Is going for an Orc build, an Orc Rider build. That guy is going for an Undead Mage build, and that guy is gonna be for like a cheesy longbow build. And that guy is like, he doesn't know what he's doing. So he has a bit of everything. So the server is gonna start the combat phase, and everyone is fighting, and it's kind of laggy. It was kind of laggy, as you could see here. But I don't know if it comes from our movement logic, from the multiplayer replication, from the FPS lag due to the fact that we have 4 windows, 4 players, I don't know. We're going to stop the combat phase, and we're going to head back to the combat phase just to see what it does. And once more. So yeah, they are lagging like hell. And it no longer works here, oddly enough. I think I know why. That comes from the unit pool. We exceeded the unit pool, I think. Yeah, because they are there here, so I think it's coming from the unit pool. But we'll see how we handle all these errors and the movement and stuff like that. For now, we're just happy that... Is it lagging with 2 player? We're just happy that we're starting to go somewhere. So yeah, it's lagging here as well, so I guess... And there are no animation, are there? Yes, there are animations. Okay, so I think I know why it's lagging like this. If we open up our units, our combat units, in the class defaults, they are being replicated only 20 times per second. If we put this back to 100, yeah, it's less laggy, but it's not really so clean. I think this might be coming from the fact that we're using floating point movements. I think. And The walk animation is not correct as well. Replicates movement. So do they have... They don't have gravity, they don't have physics. They are prone, they move on the ground. The skeletal mesh should not be an issue whatsoever. And the floating pawn movement, I think it shouldn't have any acceleration or deceleration. Just to see turning boost, I don't know what that is. Okay. Movement capabilities. Okay, so I think we won't be fixing this in that video. So hope you guys enjoyed that video and hope to see you in the next one. Bye bye.